All right, tonight we are going to learn about 4.1 from Dolciani, the Dolciani Algebra 2 book, Adding and Subtracting Polynomials. First thing you need to know is that a monomial, which you've learned before in Algebra 1, is an expression that is either a numeral or a variable or a product of one or more variables. So for example, 2x is a monomial, 2xy is a monomial, 3x squared is a monomial. Also, just the x by itself is a monomial, as is just the number by itself. A constant is just the number. So 3, it is also a monomial, and it's a constant. Next thing you need to know is a polynomial. A polynomial is a sum of monomials. Okay, so it's like we add those ones above together. Or 2 of them, or 3 of them together, right? So like 2x plus 2xy, okay? Or we could just have 3x squared plus 3, for example. Or we could add all of them together if you wanted, but I'm just going to add 3 right now. X plus 3x squared plus 2xy, for example. So all of those, in all of them, right, they can be added together. A 2x cannot be added with a xy. A 3x squared cannot be added with a 3. Only x squared can go with x squared, so numbers go with numbers. And the next one, x can't be added to x squared or xy. They all have different variables, and we can only add like terms, which we'll get to in the future, but you should know that by now. A binomial is a polynomial with 2 terms, hence the bi, right? Like a bicycle has 2 wheels, binomial has 2 terms. Trinomial is a polynomial with, you guessed it, 3 terms. Okay? And you should know that. A coefficient is the number in front of the monomial. Okay? So like for example, we have 3x. 3 is the coefficient. Okay? Similar or like terms. Again, something you should know by now, but this is just review. So something like 3xy and 5xy, those are like terms. And you could also just have xy by itself. You could even have a negative in front, okay? Those are all like terms. They all have an x, they all have a y. We could add them together, we could subtract them together, and that would be fine. A polynomial is simplified or in simplest form when no 2 of its terms are similar. Okay, so you can't add anything else and you can't subtract anything else from it because there's nothing else to add together. Okay, so for example, let's simplify this a and b. So I'm going to underline the like terms. Okay, so 3x squared and x squared. Okay, negative 3x squared and x squared. So I can add those two together because they're both x squared. And I am going to put these in a certain kind of order just because it looks more beautiful that way. And it's important that you put them in exponential order. Okay, so negative 3 plus x, which has an invisible 1 in front of it, is negative 2x squared. Okay, I have a 5x and a negative 2x, okay, which gives me plus 3x, and then this lonely number 4, it doesn't have anything but itself, okay, so this is simplified. Okay, there's nothing else I can do at this point because x squared can only go with x squared, x can only go with x, and 4 can only go with 4. So the next one, b. Okay, 4m squared plus 5mn squared, those are different, minus m squared plus 3mn squared. Okay, so I have a m squared and an m squared, which is going to give me 3m squared. Okay, and then I have my 5, which I'm going to double underline. These both have an m and an n squared, so I can add those two together, so plus 8n squared. Okay, nothing else I can do there. That's my answer. It is simplified. Okay, next, I am going to add these two things together. Sometimes it will tell us with words, add these two things together. Okay, so I'm going to rewrite it with an addition. 2x squared minus 3x plus 5 plus, because I'm adding them together, x cubed minus 5x squared plus 2x minus 5. Okay, make sure you add the like terms. I'm going to start putting them in order right away so I don't have to waste any time, or any of my energy. So I have x cubed. That's the biggest exponent, so I'm going to put that first. X cubed. Then I have an x squared and an x squared. So I'm going to combine those two. 2 minus 5, negative 3x squared. Okay, double underline my x's. Okay, I have negative 3x plus 2x, which leave me with negative 1x. So I'm going to write this as negative x. And then I have a positive 5 and a negative 5, which combine to create 0. So here is my final answer. Okay, now when it says subtract something from something, okay, that means I'm going to take this first stuff and I'm going to subtract it from that second stuff. All right, so I have x cubed minus 5x squared plus 2x minus 5. And from this entire thing, I am going to subtract, okay, 2x squared minus 3x plus 5. Okay, so I put parentheses around it because I'm subtracting the whole thing. If I just put a minus, that would look like I'm just subtracting this 2x squared, which I'm not. I'm subtracting the entire thing. Okay, so this is like there is an invisible negative 1 in front of here, and you have to distribute it to all of your wonderful terms in that parentheses. Okay, so I have to distribute that. So they're all going to change values. Okay, now I no longer need my parentheses, so I'm going to take them out. So x cubed minus 5x squared plus 2x minus 5. Okay, this becomes, when I distribute my negative, negative 2x squared plus 3x minus 5. Now what I'm going to do, I'm going to combine my like terms. Okay, so I have x cubed. I only have x cubed, so I'm going to leave that alone. Stays by itself. I have x squared, and I have another x squared. So this becomes negative 7x squared. Okay, I have a 2x. I'm going to triple underline, and a positive 3x. So that is positive 5x. And then I have my negative 5 and negative 5, which is negative 10. Okay, so circle that. That's my final answer. Okay, next in this section it also talks about the degree of a monomial and a polynomial. Okay, and the degree of a monomial is the sum of the degrees of its terms. Okay, so find the degree of this, for example. Okay, x cubed has a degree of 3. Y has a degree of 1. And z has a degree of 2. Okay, do you notice degrees are like the exponents? So if I were to find the degree of this, I add all of the exponents together. So I just do 3 plus the invisible 1 plus the 2, okay, which gives me 6. So my degree of that monomial is 6. Okay, when we do a polynomial, it's slightly different, okay? Degree of a polynomial, it is the degree of the largest monomial after it's been simplified. So you have to simplify, and then you find the degree of all the monomials, okay, and you take the largest one. Okay, so here we go. We have negative 6x cubed and positive 6x cubed. Okay, when I simplify, those go away, so I can no longer have a degree of 3. Okay, I have 3x squared and x squared, which gives me 4x squared. Okay, minus 5. So the only degree I have is 2. So the degree of that equation is 2. Okay, one more. B. All right, so I have x cubed, y cubed, minus x cubed, y cubed. Okay, and guess what? Those cancel out. Okay, and then I have xy to the 4th, and I have another xy to the 4th. Okay, so I'm going to underline those. So negative 6xy to the 4th plus 3xy to the 4th gives me negative 3xy to the 4th. Okay, I have an x cubed, no other x cubed, and then I'm going to underline this silly like that, x squared y. Okay, so I'm going to put them in order. So 2x cubed y. So I'm going to go in order of my x's, and then I have an x squared plus 4. Nope, sorry, that should be a minus. Minus 4 x squared y. And then I have, what else do I have here? Oh, I just have the xy to the 4th. So add those two together, right? So that becomes negative 3xy to the 4th. All right, so now I find the degree of each. Okay, degree of this one is 3 plus 1, which is 4. Degree of this one is 2 plus 1, which is 3. Degree of this one is 1 plus 4, which is 5. So I take the highest one. 5 is my degree. All right, enjoy your homework.